I'd like to talk to you today about a project which falls under Landcare's Strategic Technologies for Managing Pests programme. Now this is a community engagement project, and you can see we're going to go all the way from scientific models to serious games, and if you're intrigued then keep listening. Essentially what we're trying to do here is find a way to explain an incredibly complex system, which you can see on the horrendogram here, to the stakeholders involved in that system. Everyone from scientists to managers to landowners to hunters to people who just want to be able to walk their dogs through the countryside and enjoy it. And the problem is that managing this system for biodiversity is what we call a wicked problem. It's incredibly complex. There's a lot of interactions. How do the invasive and native flora and fauna of New Zealand interact with each other? How does management affect that? But it's also got limited resources. That's time, money, equipment, people. And it has multiple stakeholders, all of whom have conflicting views. And so in order to solve this problem, to work out what to do to manage the system, we have to get those people to even agree what the problem is in the first place. So what it comes down to is managing people rather than pests. To agree what the question is and then move forward to discussing action, it's important that all the stakeholders are well informed about the scientific research that's gone on about this system, both in terms of solid science, interactions between those animals, but also social science, what the communities want from this system, what their conflicting views are, and what compromises they're willing to accept. So what we need is information flowing in both directions, from managers to the people, and the people back to the managers and the scientists. Previously, scientific knowledge transfer has perhaps been less useful than it might be. You can see scientific knowledge transfer within science might be live and well in terms of papers, but for the man on the street it's quite hard to understand these papers. Even going to workshops or through word of mouth only disseminates that knowledge to a small number of people. And it's difficult to get a wide audience really engaged with the problem. Publications don't look particularly interesting. You wouldn't really sit down with them for bedtime reading. And so what we want is a way of getting that science to people who wouldn't otherwise engage with it. One of the best ways of doing that is to really interact with that problem, to be part of it and to be able to poke it and see what happens when you change something. And that brings us to computer games. So you can see here one of the very first pest control computer games ever invented. Dates back to the mid-80s. It's called Ghostbusters. What happens is you're given a franchise. You have a limited budget and you have resources to clear the city of ghosts. Only the accepted registered equipment is available for use, and only if you can fit it into your car. But you get feedback from the game in terms of how well you're doing, how many ghosts have you caught, what the energy of the city is at. And you have clear missions that you have to complete. Rid the city of the ghosts. A similar approach, but in a more modern pest control game, is called Plants vs. Zombies. This is a more complex system. The threats, such as the zombies, differ in their speed and their likelihood to get to your brains. In the meantime, the equipment, which is the plants, have all manner of different skills that you very quickly get the hang of, because you don't want the zombies to eat your brains. So you're engaging with that problem and you're absorbing all of that information without really realizing it. And it's incredibly addictive, so I don't recommend downloading it at work. But that's the point. The longer you play it, the more information you absorb about all the different things that are happening in that system. So what we'd like to do is take the science that's been done to do with pest control in New Zealand, recast the zombies as the invasive pests, and the brains as biodiversity. And what we come up with is a game which we think everybody will want to play. What we're trying to do is integrate scientific models, operational models and economics into one big system which has an engaging interface which will inform stakeholders about all of the options for pest control. But at the same time, that also gives us an opportunity to learn how real people manage those pests when it's their own fingers on the trigger. So what we've been doing is integrating all these models from possum dynamics, birth, death and dispersal, their impacts on native flora and fauna, and their interactions with management tools such as traps and baits and fences, and put that into an economic framework with control operations. How do you manage and how do you budget for doing those operations? And we've created a spatial model. Possums forage among the trees which are within their home ranges. Trees have different palatability, and then the possums have the potential to fall into traps, pick up bait that you've put out, and sometimes that has fatal consequences. But what differs to other models is that we've also got that whole operational layer in there as well. So how long does it take to fly your helicopter over the land that you want to control? How much do contractors cost? How many days are they in the field? What route should they take to walk around all of their traps? And all of that costs money and it costs time, and that's part of the model as well. So just to convince you that that integrated model does something sensible, I've got a few results here from some simulated tree monitoring operations. So you can see the number of questions up here that you have to think about when you're planning this kind of system. And this is something that people in general might not think about. You say, let's go and check the health of the forest, and they think, oh, we'll just take a wander through and look at the trees. But in fact, to do it scientifically and to do it on a budget, these are all of the things that you have to think about. And this is what the model will prompt people to do. So here we've got coloured dots, which are individual tagged trees, and the symbol indicates what species they are. The black dots are the mean for the species. So we've got foliage health up the y-axis, and then we've got time along the x-axis. And the colour of the dot tells you how browsed that tree is by possums. So those are all green at the beginning. Our trees are healthy. We send people out every 6 months to have a look at those trees. That's excessive for real life, but in a model you can do what you like because your budget is virtual. And you can see that individual trees get browsed. One species gets browsed more than another, which we would expect because rata is more palatable than carmahy. But there's variation between individual trees, which is again what you see in real life. And at this point we might think, well, a few trees are beginning to die, perhaps we ought to do something about it. So we set up an operation in the model which will do aerial baiting. That kills most of the possums. And after that, most of the remaining trees eventually recover. So you can see it's realistic behaviour, which can get across the concepts as well as the quantitative numbers involved in this pest control process. Now what we're doing is we're building two interfaces to this model, because we realised we're putting together this big model, we could actually use it for real science as well as for education. So the science interface is unlimited in that every registered piece of equipment that we can think of to put in there is available. Managers can instantly try out and play through management strategies that they fancy doing in their area. So we've just built a version of this for Hawke's Bay. And you load in a digital elevation map and the forest composition. You can play around with your costs, and then you can play through operations and see what happens. Try something that you might not be willing to try in the field because it takes too long to find out what the impact will be. The problem is, for people who aren't engaged in this process every day, there's a very steep learning curve to figure out what's going on, what should I do, how should I do it. What the game will do is lead people through that learning process. So it smooths out the learning curve, gives them simple missions in small areas, save this one tree from this one possum with this one trap type. And when the player has grasped the necessary skills for that stage, only then will the game move on to the next stage and say, hey, we've got this more complex system, there's more than one tree, there's more than one possum, there's a whole range of pieces of equipment that you could use. And we're hoping that because the whole system is engaging, people will say, I've got a warm fuzzy feeling for saving my first tree, I'll keep playing, I'll find out a little bit more about that system. The game can give you extensive feedback, much more so than a science-looking model can. So it moves quicker than real life, so you can get to the end of 20 years of mission in maybe an hour's play. And that'll engage your player to really care about that system. They can see the whole thing. The forest is turning red, the possums are crawling up the trees, you've got them around your knees. Maybe you ought to spend some money and see what you can do in that system. Similarly, the game gives a lot more incentive to keep playing. It's interesting. You saved your first tree, so you got a little mini game. You got your name on the online league tables. Everyone likes a bit of competition. The longer you play the game, the more engaged in that you get, the more information you'll absorb, and that will help us to inform stakeholders so that when they come to talk about a real system, they think, yes, I remember when I was managing the 100 hectares on a limited budget, I couldn't necessarily do everything that I wanted to. I've got to find a compromise. But finally, that game makes the science that underlies this whole thing available to absolutely everybody. It's no longer buried in a heap of dry publications. It's integrated into this one system, which anyone with the internet can download and play. And it gives us the opportunity to bring in the social side of the problem as well, which a more scientific, let's just play through a management strategy model doesn't give us. So we can have areas where the landowners won't allow poison. We can have areas that are adjacent to livestock. We can have areas where the rules are different. And people will have to find a way around that, work out how to manipulate the world to get the result that they want. Now we'll be testing the pilot level of this game by taking groups and giving half of them the science model and half of them the game model, and to see which group of people retain those learning goals that we've embedded into the game for a longer period, and who plays longer, who gets more from it. And then what we're going to do is we're going to release that game over the internet, and so anyone will be able to play it. But what we'll do is we'll suck back the strategies that every player uses, so we'll be able to see what people are doing when it's them that's doing the management and it's them that has the budget. And we will analyse that and see if we can actually learn anything from the people playing the game. So what next? Well, we'd like anyone who's interested to get involved. So if you've got groups of people who might be interested in having the game tested on them, then get in touch. If you've got dollars to spend and you'd like your own version of the science model for your particular management area, then we can talk about that. Or alternatively, if you've just got a great idea for a mini game or a level of the game, then we're very definitely interested in what you have to say. And if you have ideas about how to expand the model into the future, what we'd like to do is include multiple pests to move beyond forests into pasture land and that kind of thing, then let us know. Thank you very much.